but they're centered at 0. Maclaurin series, Maclaurin. So the Maclaurin series is a special case Taylor series with a equals 0. So what does that mean for my formula? Well, that would mean f of x, whatever my function is I'm trying to write the power series for, is the sum n equals 0 to infinity. For the Taylor series, it's the nth derivative at a over n factorial x minus a to the n. But what we're saying is a is 0. So I need to find the nth derivative at 0 formula, divide that by n factorial, and then x minus 0, hey, that's just x to the n, isn't it? Since a is 0, that last part is just x to the n. So when they want Maclaurin series, this is what you go with. All right, so let's find a couple of those. Find the Maclaurin series 4. F of x equals e to the x. The only thing about the Maclaurin series is it doesn't tell you the center because the center is automatically 0. Just have to remember that. But this is what we do. Okay. So what do I do to find it? Same thing as before. Find the nth derivative formula. All right, so just doing the first few derivatives, my f of x is e to the x. Oh, that's pretty nice, isn't it? What's the first derivative? E to the x. What's the second derivative? Okay. I'm not going to do many of those because it's always e to the x. But now I need to compute those at 0. X equals 0. So that'd be f of 0. It's e to the 0. F prime of 0 is e to the 0. It's 1, 1. Ooh, this one works out really nicely, doesn't it? What's the nth derivative? At 0. Uno. Yep. That's what turns out really nicely. E to the x, the nth derivative at 0 is just 1. Derivatives are all 1 at 0 for this one. Okay, so we're going to plug that into our Maclaurin series formula here. See what happens. Oops, erased my problem. So it's going to be f of x is e to the x equals the series n equals 0 to infinity. Well, the nth derivative at 0 is 1. I erased it, but we all remember what it was. N factorial x to the n. Or, if you want to, just write that. N equals 0 to infinity, x to the n over n factorial. Start off an easy one. Okay? No problem? So far, so good. All right. Well, let's get some. Same thing can happen on these. You know, you get your n factorial, all that stuff. But see what else can happen. Here's another one. All right. So let's find the Maclaurin series, which is the series n equals 0 to infinity. Nth derivative at 0 over n factorial x to the n. Okay. So let's find one of those, 4. Find the Maclaurin series 4. How about we do f of x equals sine of x? Well, this one does an interesting little thing. All right, so my first derivative is cosine. Second derivative is negative sine. Third derivative is positive cosine. And the fourth derivative is third derivative is negative sine, so the second derivative is negative sine, so the third derivative would be negative cosine. So what's the fourth derivative? Positive sine. And if you'll notice there, what's happened? We're back to where we started up here, sine, so the pattern will continue here. All right. But for the Maclaurin series, we need to compute at x equals 0. Compute at 0. All right, so f of 0, what's f of 0? Sine of 0? What's sine of 0? 0. First derivative at 0. First derivative at 0 would be cosine of 0, which is 1. So second derivative at 0. Second derivative is negative sine of 0, which is still 0. Third derivative at 0. Third derivative at 0 will be negative of cosine of 0, which is negative 1. And then the cycle starts all over again. Won't it? Because won't the fourth derivative be the same as the first one? Fifth derivative will be the same as the second one. Because our pattern has just started again, right? At the fourth derivative, it's back to sine, so it would be 0, 1. All right, so that's our pattern. Well, so it's just going to keep rolling 0, 1, 0, negative, 1, 0, 1. What are we going to do with that? Well, let's just forgo a formula for that, and let's just plug these in to our formula right here in our series. So we're going to say f of x equals sine of x equals this series, n equals 0 to infinity, nth derivative at 0 n factorial x to the n. All right, so our pattern is, I'm going to need a little space here, so 0, 1, 0, negative 1. Okay? Where do I want to put that? So f of 0 was 0, f prime of 0 was 1, f double prime of 0, just so I can, 0, third derivative of 0 was negative 1, and then it cycles from there. Okay? So I'm going to plug those in to this formula. All right, because this means, like I said, this is f, the 0th derivative, which is just the function, 0 over 0 factorial x to 0. So this is just going to write these terms out term by term. F of f first derivative at 0 divided by, this is n equals 1. Just doing n equals 1 here. N equals 0 is the first one here. Then I'm going to do n equals 2. It's n equals 2. Well, it would be the second derivative at 0 over 2 factorial. Whoops, what happened to x? X to the first should be here. This would be x squared. And then that's n equals 3. We'll have the third derivative at 0, 3 factorial x cubed. Go one more. F to the fourth derivative, 0, 4 factorial, x to the fourth, and then so on and so forth. All right, so let's plug in for these. This one would go here. 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 0 over 0 factorial x is 0. 1 over 1 factorial x to the 1. 0 over 2 factorial x squared. Negative 1 over 3 factorial x cubed. You see what's happening? What's happening? What's 0 over 0 factorial times x to 0? 0. What's 0 over 2 factorial times x squared? That's 0. That's 0. What's happening? What terms are left? Odd ones, you might say? The odd ones are all that's left. Yeah, because of those terms that zeroed out here, if your derivatives, whatever, those zero out, then that means your whole term right here zeroes out in your series. So what's left? Only the odd powers, odd ones are left. All right, so can't we make that into, this would be 1 over 1 factorial x to the 1. Negative 1 over 3 factorial x cubed. What will be the next one? What will be next? 1 over 5 factorial x to the 5th. What will be next? Negative 1, yeah, because also notice they're odd, but they're alternating signs there too. Okay, so I think that gives us a pretty good little pattern. Okay, so how are we going to do that? Well, turns out if we want to restart here, let's say we go back to n equals 0 to infinity. However, all that's left are the odd ones, the odd terms. Well, I can do that with a little expression we like to call 2n plus 1. Okay. Let's take a look at this. Oh, sorry. This one's easy. Negative 1 to the nth, obviously, because I'm alternating signs. So I've got negative 1 to the n. But then the bottom, oops, forgot something. Try this one on for size. Yeah, if I go with consecutive integers, 2n plus 1 only hits the odd ones, doesn't it? Because at n equals 0, that's 2 times 0 plus 1, that's 1 factorial. That's x to the 0, x to the 1, right? That would give me, the first term would be that, wouldn't it? At n equals 1, the second term for this, well, it would be 2 times 1 plus 1, which is 3 factorial, x to the third. And then that would be negative 1 to the 1, which is negative 1. Then the third term would be n equals 2, which would be 2 times 2 plus 1, which is 5 factorial, x to the 5, positive. So this does it. So if you got some terms zeroed out, then you'll have to do something like that to that effect. If they're the odd ones. What if they were the even ones? Just to throw out a hypothetical there. What if they were the even ones? Well, instead of 2n plus 1, how would I get even ones out of it? Just 2n. Just 2n. 2n would get the even ones. It would get n equals 0, because 2 times 0 is 0. 2 times 1 would be 2. I got one more. So yeah, if you've got just the even ones, then you go with 2n. Yeah, let me do one more with you, and then we'll pick up on that note next time. Is that okay, though? So that's for sine of x. Sine of x has that. Okay, so find the Maclaurin series for f of x equals e to the x over 3. So I need to start by finding an nth derivative at 0 formula. All right, so f of x is x over 3, e to the x over 3. What's the first derivative? Well, the first derivative at x would be e to the x over 3 times derivative of x over 3, 1/3. F second derivative would be, so this is 1/3 e x over 3. All right, second derivative would be 1/3 times the derivative of e to the x over 3 would be 1/3 e to the x over 3. So that'd make it 1/9 e to the x over 3. Third derivative would be 1/9 times the derivative of e to the x over 3, which is 1/3 e to the x over 3, which is 1/27 e to the x over 3. With me? Fourth derivative. Maybe we can see what happened. 1/27 times the derivative of e to the x over 3, which is 1/3 e to the x over 3, which is 1/81. 1/81st? Something like that. E to the x over 3. All right. But I want those at 0. So I want to do f of 0. That's e to the 0 over 3. That's 1. Right? F first derivative at 0 is 1/3 e to the 0 over 3. Well, that's 1/3 times 1. That's 1/3. Second derivative at 0. Well, being at 0, this is making this pretty nice. It's 1/9 e to the 0 over 3, which is 1/9. What's the third derivative? Well, since I'm doing it at 0, that's going to be 1, so that's 1/27. Third derivative. And then the fourth derivative is 1/81st. What is my pattern? I don't have the 0 thing happening here. But what's the nth derivative then? Well, the e part goes out altogether, so there's no e part to this. All that's left are 1, 1/3, 1/9, 1/27, 1. What are the denominators here? Powers of 3, yeah. That's 3 squared. 3 to the first, that's 3 squared. That's 3 to the third, that's powers of 3. 3 to the fourth. And even this one works because that's 1 over 1, so that's 3 to the 0, isn't it? Yeah, it's 1 over 3 to the n. And not even any alternating signs. Just 1 over 3 to the n. So what does that mean for my Maclaurin series? So the Maclaurin series would be, plug that in right here. So my f of x e to the x over 3 would be equal to the series n equals 0 to infinity. The nth derivative of 0 is 1 over 3 to the n over n factorial x to the n. Gonna clean that up some? We could say, what? 1/3 x to the n. Okay, I see what you're saying. Is that what you said? Okay. We could write it this way, couldn't we? How about we do this? There's different ways of writing it. Could write that way too. Take your pick, I guess. Probably one of these two, but or something vaguely similar to it. Oh, here's another way. For some reason, I have it written this way.